NASA's space test has sent a stunning cautioning to Earth. Explorer 1 has acquired the trust of science lovers across the world for its exceptional excursion through the depths of space. Initially intended for a 5-year life expectancy, this tough space apparatus has resisted all assumptions, persevering for almost 5 decades now. We are very near a earth-shattering revelation, as Explorer 1 has identified obscure objects cruising by in space. What are these unidentified flying objects? Join us as we uncover how Explorer 1 identified 300 obscure objects cruising by in space. We wonder at the amazing magnificence of Earth's natural wonders, the flowing waterfalls, transcending mountains, and lively environments. It is difficult to understand that our planet is just a brief look at the loftiness that awaits us in the endlessness of space. For years, researchers have considered the secrets that lie beyond our nearby planet group and the careful look of the Sun. Luckily, Explorer 1 emerged as humankind's most aggressive endeavor to seek answers to immortal questions. This surprising shuttle has wandered past the limits of our most remarkable telescopes, gathering first-hand information about the tremendous spread of interstellar space and transmitting it back to Earth. After many years of a remarkably successful journey, Explorer 1 has delivered a frightening message that has left researchers dumbfounded. NASA's most trusted interstellar space apparatus recently declared that it has identified 300 obscure objects passing by in space. But before we uncover the secret behind these unidentified objects, let's first explore one of the most amazing accounts of humankind's exploration of space. In August 2012, an exceptional achievement was accomplished by the Explorer shuttle. After a remarkable journey, Explorer 1 officially reached the peripheral limit of our nearby planet group, crossing what is known as the heliopause. However, this accomplishment was by no means a simple task. As Explorer 1 wandered farther away from the Sun, the availability of sunlight to power its instruments and systems decreased significantly. The primary source of power for the rocket comes from 3 radioisotope thermoelectric generators, RTGs. These brilliant devices convert the heat generated by the natural decay of plutonium-238 into power. Over time, challenges such as the declining heat output of the RTGs have led to a decrease in available power. This reduction in power directly impacts the operation of various systems on board, including scientific instruments, data transmission, and communication abilities. To conserve energy, certain unnecessary systems and instruments have been deactivated or put into a dormant state. However, as the power continues to decline, critical systems may require further shutdown or even closure to extend Explorer 1's operational life. The stark truth is that, without action, Explorer 1's ability to function will be severely limited. Adding to the challenges is the vast distance between Explorer 1 and Earth. As the shuttle ventured into interstellar space, the strength of the signal transmitted from Explorer 1 weakened significantly. It currently takes more than 21 hours for signals to travel from Explorer 1 to Earth. The weak signal, combined with interference from background noise, presents a major obstacle to effective data transmission and reception. Furthermore, the transition from the heliosphere to interstellar space exposed Explorer 1 to dramatically different temperature conditions. Within the heliosphere, the rocket was closer to the Sun and experienced higher temperatures. However, as it dove into interstellar space, it encountered extremely low temperatures. These temperature extremes can affect the rocket's materials, electronic parts, and systems. Thermal stress and the expansion and contraction cycles caused by these temperature variations could potentially compromise the structural integrity of certain parts. Extreme cold can cause materials to become brittle, leading to potential cracks or degradation of seals and connectors. Additionally, the temperature variations also impact the performance of the RTGs, which are designed to operate within specific temperature ranges. The cooling of the RTGs further exacerbates the power challenges previously mentioned. Further compounding these issues is the presence of an insufficient distribution of dust particles within interstellar space. Although these particles are minute in size, they pose a risk to the Explorer 1 space apparatus. When the rocket encounters interstellar dust, these particles can collide with its exterior surfaces, causing wear and tear on protective coatings, antenna surfaces, or other sensitive areas. The accumulation of dust on instrument optics or sensors can hinder their functionality, degrading the quality of the data. Moreover, the Deep Space Network, NASA's global array of receiving antennas for communicating with deep space missions, must allocate limited resources to receive signals from Explorer 1. This allocation of resources makes communication opportunities with Explorer 1 much more inconsistent than ever before. The ongoing decrease in signal strength further complicates the recovery of data and transmission of reliable commands. Now, let's pause here and update you on the incredible achievement of the Explorer spacecraft before the new revelation of 300 unidentified objects. The accomplishments of the Explorer twin spacecraft stand as a testament to human ingenuity and the unfathomable spirit of exploration. These remarkable spacecraft, more than 40 years ago, embarked on a journey that forever changed our understanding of distant worlds in our solar system. Their initial observations of Jupiter and Saturn's moons shattered expectations and left scientists in awe. These moons, once believed to be inert and scarred like our own moon, turned out to be dynamic and active, teeming with geological activity. Among the Explorer spacecraft, Explorer 2 stands out for its extraordinary achievements. In 1986, it made history by becoming the first spacecraft to venture near Uranus, providing humankind with the first close-up look at this enigmatic planet and its moons, just 3 years later. Explorer 2 achieved one more weighty accomplishment with a flyby of Neptune, uncovering the miracles of this frosty monster right up till now. Explorer 2 remains the sole space apparatus to have wandered into the domains of Uranus and Neptune, a demonstration of its spearheading spirit. The Explorer shuttle continued its epic odyssey. NASA executed different measures to draw out its functional life expectancy throughout the course of recent years. Superfluous parts and warmers have been deactivated, saving energy and ensuring that these courageous adventurers can continue their mission well into the next 10 years. Their estimated mission end date is set for 2030, a demonstration of the strength and solidness of the Explorer tests for the dedicated scientists and engineers who have been associated with this unprecedented effort all along. The zenith of the Explorer missions is both a snapshot of pride and a hint of despairing. Their unfaltering commitment and resolute endeavors have far surpassed their initial assumptions. The abundance of information returned by the explorers has given important insights, powered various scientific discoveries, and ignited the imagination of countless scientists and space fans. What really sets the Explorer tests apart is their meticulous design. As steady stages with a turn rate north of 15 times slower than the hour hand of a clock, these space apparatus were designed to limit visual obscuring as they captured pictures and information while tearing through the boundlessness of space. Even before their encounters with the outer planets, their great imaging capabilities began to stun researchers and the public alike. Months prior to arriving at Jupiter, the Explorer shuttle began sending pictures of this gas giant, enrapturing crowds at NASA's Fly Impetus lab. These early pictures showcased the hypnotizing twirling clouds and the iconic Great Red Spot, leaving onlookers in awe. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly got everyone's attention. This moon, somewhat larger than Earth's moon, turned out to be the most volcanically dynamic body in our system. The spacecraft's instruments identified unusual signals from Io, which were confirmed by the clear pictures they captured. Towering volcanic plumes and a surface scarred by volcanic material discharges were revealed. One of Io's most prominent volcanoes erupted with a force 30 times greater than the height of Mount Everest, covering an area nearly the size of France. While the cameras of the Explorer shuttle were eventually shut down to save power and memory before their journey into interstellar space, it is significant that the photographs they captured didn't include Mercury and Mars for various reasons. In addition to the Explorer 1 and Explorer 2 interstellar probes, NASA has also worked on other outstanding spacecraft, such as Trailblazer 10, Trailblazer 11, and New Horizons. Explorer 1 passed by Trailblazer 10 on February 17, 1998, marking the moment when Trailblazer 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for another 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other spacecraft in sight, NASA didn't publicly announce this astounding achievement until 2013, adding to the interest and wonder surrounding the Explorer missions. One strategy that really showcased in the incredible Explorer missions was the gravity assist maneuvers. These maneuvers played a crucial role in propelling Explorer 1 and Explorer 2 on their bold mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They required a lift, and gravity assists provided exactly that. Picture the two fearless spacecraft, Explorer 1 and Explorer 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they participated in a cosmic dance with some of our solar system's heavyweight planets. This intricate movement allowed them to harness the immense gravitational pull of these giants to slingshot themselves on their way. In this way, they saved precious fuel and gained the speed necessary to visit multiple destinations, leaving a lasting legacy of exploration and discovery. Discovery was the identification of 300 obscure objects, a breakdown, or something even more mysterious. As this amazing spacecraft floats through space, obediently gathering and sending valuable data back to Earth, the responsibility of analyzing this information falls on tireless researchers eager to unravel the mysteries of the universe. Recently, amid the constant flow of data, an enthralling discovery emerged, the signal that puzzled and fascinated scientists around the world. Explorer 1 had identified the presence of 300 obscure objects navigating interstellar space. These unidentified objects, emerging from the depths of interstellar space, posed a significant challenge to our current understanding of the universe. When Explorer 1 sends data, it is usually a straightforward process. However, on this occasion, the data arrived mixed and ambiguous. Numerous questions arose, but answers remained elusive. Interestingly, despite the unusual nature of the transmitted information, Explorer 1 itself remained unscathed and continued to operate in surprising condition. Its communication link with Earth remained flawless, and the signal retained its strength, allowing valuable data to be sent to NASA without significant issues. Unusually, none of the spacecraft's fault protection systems were triggered, indicating that it had not entered a defensive mode as it would in the presence of potential threats. It became clear that Explorer 1 was not under attack, leaving researchers to wonder what might be causing the mysterious signals. Mixed or mistaken telemetry information. Was it obstruction from outer enormous peculiarities like radiation or high-energy particles, or might it at any point be credited to a completely obscure peculiarity sneaking in the profundities of interstellar space? On the off chance that the last option were true, it would challenge our comprehension of space and communication in the interstellar domain. To determine the truth, a fastidious examination of different potential variables became necessary. However, the investigation team at NASA left on an intensive assessment of Explorer 1 systems. They carefully considered the effect of vast radiation on electronic parts and investigated the chance of temperature variances influencing the steadiness of its delicate instruments. It was proposed that something strange may have happened not long before Explorer 1 arrived at the heliopause, and the normal challenges experienced during the transition might have led to the scrambling of data. Anyway, it became evident that Explorer 1 was not in an area where these challenges were sufficiently thought to represent a significant danger. Subsequently, the team also examined the complexities of Explorer 1's communication systems, investigating possible signal bends caused by grandiose noise, interference, or subtle changes in its trajectory. The quest for answers required a fastidious investigation of all potential factors. The research process was not immediate, it spanned several weeks. The team used advanced data processing methods, developed creative algorithms, and simulated different scenarios to isolate the root cause of the strange telemetry abnormalities. This thorough work finally bore fruit. After weeks of receiving mixed data from the spacecraft, researchers and engineers successfully restored the clarity and reliability of the data coming from the far reaches of interstellar space. The source of the issue was traced back to Explorer 1's Attitude Control System, ACS, more specifically to a surprising source, a lethargic onboard computer. Surprisingly, this non-functional computer had somehow started working, leading to the degradation of the sent data. Nevertheless, the rest of the spacecraft's systems remained functional, and data collection activities continued unhindered. With the source of the problem identified, engineers quickly formulated a solution. They sent a command to Explorer 1, instructing the ACS system to switch computers for transmitting telemetry data, a process complicated by the 22-hour radio transmission delay between Earth and the spacecraft. The solution involved consulting 1970s manuals to reset the system responsible for data transmission, which successfully resolved the issue without compromising other parts of the spacecraft. This rebuilding highlighted the importance of integrating past data with present technology in overcoming challenges in space exploration. Engineers suspect that a flawed command set off Explorer 1's deviation to a non-functional computer, but mission administrators remain hopeful, emphasizing that the incident doesn't undermine Explorer 1's long-term success. Explorer 1's successful entry past the heliopause marked its entry into interstellar space, and ensuing observations, including changes in particle power and magnetic field, extended our understanding of the heliosphere's limit and interstellar elements. The experience also raised questions about unidentified objects detected by Explorer 1, prompting hypotheses about rogue planets, ancient interstellar objects, and possible extraterrestrial involvement. This has sparked ongoing scientific investigation into the true nature of these objects and Explorer 1's encounters. Furthermore, the restoration of Explorer 1's telemetry data highlighted the resilience and versatility of both the spacecraft and the team behind its operation. It demonstrated the meticulous problem-solving skills and dedication required for successful space exploration, particularly in the face of unexpected challenges. Additionally, Explorer 1's journey into interstellar space continues to provide significant insights into the dynamics of the universe. Its observations of particle power, magnetic fields, and other peculiarities shed light on the interactions between our solar system and the broader interstellar environment. Moreover, the discovery of 300 unidentified objects by Explorer 1 has reignited interest and speculation within the scientific community. Researchers are eager to delve deeper into the nature of these objects and explore their potential implications for our understanding of the universe. Explorer 1's ongoing mission serves as a testament to human ingenuity and curiosity. Despite the passage of nearly 50 years since its launch, the spacecraft continues to push the boundaries of exploration and expand our knowledge of the cosmos. All in all, Explorer 1 remains a brilliant example of humankind's quest for knowledge, and its remarkable accomplishments and ongoing discoveries inspire awe and wonder, reminding us of the vast possibilities that lie beyond the confines of our own planet.